The next question, we are asked 1 minus I raised to power 4 is equal to that. So let's convert it to polar form first. If you remember this one, okay, let's graph so that we can find our argument. So from the graphing, 1 minus I, so it should be here, minus I and 1. So I'm using remember the actual argument moves in anti-clockwise, so I'm using the negative. This is 1. So our theta is minus pi over 4, while our modulus is root 2. So we write this 1 minus I raised to power 4 as root 2 cos pi over 4, because cos minus pi over 4 is cos pi over 4 plus minus I sine pi over 4. So we now raise it to power of what? 4. Using our De Moivre's law. So this is root 2 raised to power 4 cos 4 times pi over 4 minus I sine 4 times pi over 4. So which is this, have this 2 raised to power 2, 4. Why this is cos pi minus I sine pi. And we know that cos pi is minus 1. Why this is 0? So our answer is minus 4. So our answer is B. The next question, we are asked to find the 3 cube roots of minus 8. So let's just graph this first. Let's get our argument. This is the real part. Imaginary minus 8 pi is at, remember, this should be negative. So our 8 minus 8 pi is that. Because this is negative. The real part is 0. So meaning our argument is either this or this. But it seems, let's use the negative one. This is positive, this is negative. So we have minus pi over 2. Okay, let's use it and solve. That's our theta is minus pi over 2. Why our modulus from this, the length is 8. Check it. 0. This is 0 squared plus minus 8 squared. So the answer is, our modulus is 8. So let's now find the nth root. Do you remember? You don't need to waste our time. Each of the nth roots differ by it. So I'm saying that from our complex number, the nth root is always r 1 over n cos theta plus 2 pi k over n plus I sine 2 pi theta plus 2 pi k over n. So in this case, our n is 3. So we are using k for k must be 0, 1, 2. So we need to find, it must have 3 values. So we are saying that 8 minus 8, when k is our first value, when k is 0, is now our r is 8. 8 raised to power 1 over 3. Remember, I told you don't need to do 0. So our n is 3. So we have cos theta, which is pi over 2 over 3, which is 6. Okay, let me just substitute. This minus pi over 2 plus 0 over 3 plus I sine minus pi over 2 plus 0, because k is 0, no need of writing that. So the first value is 2. This is cos minus pi over 6, which is pi over 6 for cos, and minus for sine. So I remember cos pi over 6 is cos 30. Cos 30 is root 3 over 2. Y sine 30 is half. So the first value is root 3 minus I. So our first root is root 3 minus I. We don't need to waste time in the second and the third one, because since we've gotten the first argument as minus pi over, so I'm saying that since theta 0 is minus pi, that's the argument for the when k is 0 is minus pi over 6. K1, theta 1 is now minus pi over 6 plus 2 pi over 3. So you don't need to waste your time. Each of them differ by 2 pi over n, and n is 3. So we have 2 for this 3 pi over 6, which is pi over 2. Do you get what I did? I just added 2 to 4 pi. So 4 pi minus pi is 3 pi. So why the argument, the last argument, is now pi over 2 plus 2 pi over 3, which is 3 pi plus 4 pi is 7 pi over 6. So these are the arguments here. So we are using this. So our second root is now 8 1 over 3 cos 7 pi over 6 plus I 7 pi over 6, which is this 2 cos pi over 6 is pi over 6 is 30, so cos 210 is cos 210, which is minus cos 30, which is minus root 3 over 2. The same thing, minus I root 3 root half, because sine 30 is. So we have minus root 3 minus I. So why the last root is now 8 1 over 3 cos, okay, I did for 7 pi, okay, pi over 2 plus I sine pi over 2, which is 2 cos 90 0, y sine 90 is 1. So the answer is 2i. So our roots, they said something. They say we should graph this root in a complex plane. So we graph. This is just a circle. This is just a circle. So this must be a circle. Remember the first one. The first is root 3 minus I. Root 3 minus I. Root 3 minus I, which is something here. This is root 3. So this is root 3 minus I. So it's a circle with the same modulus. So that's the first one. Why the second one is minus root 3 minus I. Minus root 3 minus I. So that's same here. This is minus root 3 minus I. is a circle. Remember, our modulus is 2. So y, the final one, is 2i. So 2i. So the modulus is the same thing too. So this is omega O. This is our omega O. This is our omega, okay, omega 2. Why this is omega O? Why this is omega 1? So that's it. It's always a circle with the radius, the modulus.